Hello, my name is Ludo Waldman. I'm a researcher at CWTS, the Center for Science and Technology Studies of Leiden University in the Netherlands. I'm one of the people responsible for the CWTS Leiden Ranking. In this video I will tell you about the new 2015 edition of the Leiden Ranking. I will first give a general introduction into the Leiden Ranking. I will then discuss the data on which the ranking is based. Next, I will explain the indicators that are provided in the ranking. Finally, a short demonstration of the Leiden Ranking website will be given. This will be done by my colleague Nees-Jan van Eck. Let me now start by introducing the Leiden Ranking. The Leiden Ranking is a global university ranking based on bibliometric indicators. The 2015 edition of the ranking includes 750 universities worldwide. The Leiden Ranking is focused exclusively on the scientific performance of universities. The ranking doesn't take into account other dimensions of university performance, such as teaching performance. Three aspects of the scientific performance of a university are considered in the Leiden Ranking. These are output, impact and collaboration. Statistics on these three aspects of scientific performance are calculated by counting publications, citations and co-authorships. There are a number of key differences between the Leiden Ranking and other university rankings. Compared with other rankings, three key strengths of the Leiden Ranking are the high quality of the data collection, the advanced bibliometric indicators included in the ranking, and the methodological transparency of the ranking. Another difference is that, unlike some other university rankings, the Leiden Ranking doesn't depend on data provided by universities themselves. The Leiden Ranking also doesn't rely on questionable survey data. Finally, other university rankings sometimes aim to provide a kind of overall assessment of a university by aggregating different dimensions of university performance into a single overall indicator. At CWTS, we believe that providing a meaningful overall assessment of a university is not possible. The Leiden Ranking therefore focuses on a single dimension of university performance, namely the dimension of scientific performance. I will now discuss the data on which the Leiden Ranking is based. The Leiden Ranking is based on data from Thomson Reuters Web of Science database. More specifically, the ranking uses data from the Science Citation Index Expanded, the Social Sciences Citation Index and the Arts and Humanities Citation Index. There are three reasons for using Web of Science. First of all, Web of Science is a multidisciplinary database that includes data from all fields in the sciences, the social sciences and the arts and humanities. Second, Web of Science has a good coverage of international scientific literature, which is the literature on which the Leiden Ranking is focused. And third, Web of Science generally offers high data quality. It should be mentioned that the Leiden Ranking doesn't take into account conference proceedings publications and book publications. This is an important limitation in certain research fields. The Leiden Ranking doesn't simply consider all publications indexed in Web of Science. Instead, the Leiden Ranking is focused on a subset of all publications in Web of Science, the so-called core publications. Essentially, core publications are publications in international scientific journals. CWTS has developed algorithms for distinguishing between core and non-core publications. Publications that have not been written in English and publications in non-international journals are classified as non-core publications and are therefore excluded from the Leiden Ranking. The same applies to publications in journals that have only a very small number of citation links with other journals. This includes trade journals and popular magazines, but also many journals in the arts and humanities. Furthermore, retracted publications are also excluded from the Leiden Ranking. The reason for excluding non-core publications from the Leiden Ranking is not that these publications should be regarded as unimportant. Instead, the reason is that in order to make proper comparisons between universities from different countries and universities with different scientific profiles, one needs to focus on a more or less homogeneous set of publications suitable for citation analysis. By excluding national journals, trade journals and many arts and humanities journals, such a set of publications is obtained. These two plots show the effect of leaving out non-core publications. The left plot shows that about 30% of all journals in Web of Science are left out. However, these tend to be relatively small journals. In the right plot, it can be seen that only about 15% of all publications in Web of Science are left out. How to identify the publications of a university? This may sound like a simple question, but this is actually quite difficult. This is because the name of a university is often written in different ways in different publications. In addition, many publications can be considered part of the output of a university, even though the name of the university is not explicitly mentioned in the address list of the publication. This is the case especially for publications from hospitals that are associated to universities. To deal with the problem of identifying the publication output of a university, an advanced address cleaning methodology has been developed for the Leiden ranking. This methodology works partly in an algorithmic way, but it also relies on a lot of manual data cleaning. The methodology ensures that different variants of the name of a university are unified. It also implements a policy for handling publications of hospitals that are associated to universities. The address cleaning work for the Leiden ranking is carried out by 3 colleagues of mine, Clara Calero, Martijn Visser and Andrea Reyes Elizondo. They have been working very hard to make sure that the data underlying the 2015 edition of the Leiden ranking is of the highest possible quality. The Leiden ranking includes the 750 universities worldwide with the largest publication output in Web of Science. To identify these universities, the Leiden ranking focuses on publications from the period 2010-2013. Only core publications are considered. Also, only research articles and review articles are taken into account. This, for instance, means that letters, editorials, book reviews and other special types of publications are not counted. Furthermore, collaborative publications are counted fractionally. I will explain this in more detail later on. It turns out that the university needs to have about 1100 fractionally counted publications in order to be included in the 2015 edition of the Leiden ranking. I should note that universities don't need to apply for inclusion in the Leiden ranking. The universities belonging to the top 750 worldwide, in terms of Web of Science publication output, are identified automatically during the production of the Leiden ranking. Universities themselves don't need to take any action to be included in the ranking. As you can see in this figure, Europe contributes the largest number of universities in the Leiden ranking, followed closely by Asia. North America is in the 3rd position. The Leiden ranking also includes a small number of universities from other parts of the world, including Africa and South America. In the Leiden ranking, publications are classified into 5 broad fields of science. This is done as follows. There are about 1.1 million core publications per year in Web of Science. Using a sophisticated computer algorithm, these publications are grouped into about 4,000 research areas. This is done based on citation relations between the publications. The 4,000 research areas can be linked to the 250 scientific fields defined in the Web of Science database. And these fields in turn are linked to the 5 main fields distinguished in the Leiden ranking. In this way, each individual publication is assigned to at least one of the 5 Leiden ranking main fields. The 5 main fields of the Leiden ranking are biomedical and health sciences, life and earth sciences, mathematics and computer science, physical sciences and engineering, and social sciences and humanities. I should note that mathematics and computer science is defined in a broad way and also covers closely related fields such as statistics, operations research, and electrical engineering. The social sciences and humanities main field also includes psychology. Because the Leiden ranking is restricted to core publications, only a small share of all humanities research is actually covered by the ranking. I have now discussed the data on which the Leiden ranking is based. I will proceed by explaining the indicators included in the ranking. The Leiden ranking includes 3 types of indicators. Indicators of output, calculated based on publications, indicators of impact, calculated based on citations, and indicators of collaboration, calculated based on co-authorships. The indicators are based on publications from the period 2010-2013. Only research articles and review articles are taken into account. Other types of publications are not considered. There is only one indicator of output in the Leiden ranking, which is simply the number of publications of a university. There are multiple indicators of impact and collaboration. Before discussing the impact and collaboration indicators in more detail, I should mention that each of these indicators has two variants, a size-dependent and a size-independent variant. Size-dependent indicators are obtained by counting the absolute number of publications of a university that have a certain property, while size-independent indicators are obtained by calculating the proportion of the publications of a university with a certain property. For instance, the number of highly cited publications of a university and the number of publications of a university co-authored with other organizations are size-dependent indicators. The proportion of the publications of a university that are highly cited and the proportion of a university's publications co-authored with other organizations are size-independent indicators. In the case of size-dependent indicators, universities with a larger publication output tend to perform better than universities with a smaller publication output. Size-independent indicators have been corrected for the size of the publication output of a university. So when size-independent indicators are used, both larger and smaller universities may perform well. The size-dependent and size-independent perspectives provide complementary information, and it is therefore recommended to users of the Leiden ranking to take into account both perspectives offered by the ranking. Let us now take a closer look at the impact indicators available in the Leiden ranking. 3 impact indicators are provided in the ranking. One indicator is obtained by counting publications of a university that belong to the top 1% most highly cited publications of their field and publication year. The other indicators are obtained by counting publications of a university that in terms of citations belong to the top 10% or top 50% of their field and publication year. All 3 indicators are field normalized, and the indicators can therefore be used to make comparisons between fields and between publication years. The indicator based on top 10% publications is presented as the default indicator on the Leiden ranking website. The size-dependent variant of this indicator ranks universities based on their absolute number of top 10% publications, while the size-independent variant ranks universities based on their proportion of top 10% publications. If a university has a proportion of top 10% publications that is above 10%, the university can be said to perform above the world average level. A few comments need to be made on the calculation of the impact indicators in the Leiden ranking. First, I need to explain how fields are defined in the calculation of the impact indicators. As already mentioned earlier, in the Leiden ranking, a computer algorithm is used to group publications into about 4,000 research areas. These 4,000 research areas are the fields within which the top 1%, top 10% and top 50% most highly cited publications are identified. Second, it is important to be precise on the way in which citations are counted in the Leiden ranking. Citations are counted until the end of 2014. Since the ranking is based on publications from the period 2010-2013, this means that each publication has at least one full year to receive citations. Only citations given by core publications in Web of Science are counted, and author self-citations are excluded. A citation is classified as an author self-citation if the citing and the cited publication have at least one author name in common. Finally, it should be mentioned that by default the impact indicators in the Leiden ranking are calculated using a so-called fractional counting methodology. This means that less weight is given to collaborative publications than to non-collaborative ones. Consider for instance this publication. It includes 3 addresses. The first 2 addresses belong to Leiden University, while the third address belongs to Delft University of Technology. In the calculation of the impact indicators in the Leiden ranking, the publication has a weight of 2/3 for Leiden University and a weight of 1/3 for Delft University of Technology. Only publications authored by just one university without any external co-authors have a full weight of 1 in the fractional counting methodology of the Leiden ranking. The use of a fractional counting methodology is necessary in order to ensure that impact indicators are properly field normalized and that valid comparisons can be made between, for instance, universities active mainly in biomedical research and universities focusing on engineering or social sciences research. We now turn to the collaboration indicators provided in the Leiden ranking. The ranking offers 5 collaboration indicators, all based on co-authorships of publications. An indicator of inter-organizational collaboration is obtained by counting publications of a university that have been co-authored with other organizations. An indicator of international collaboration is obtained by counting publications of a university that have been co-authored with organizations in other countries. The third indicator is about collaboration with industry. This indicator is based on publication of a university co-authored with industrial partners. The last 2 indicators are about short and long distance collaboration. The short distance collaboration indicator is based on collaborative publications of a university for which all co-authors are located at a distance of no more than 100 kilometers from each other. This indicator aims to capture the idea of regional collaboration. The long-distance collaboration indicator is based on collaborative publications of a university with co-authors located at a distance of more than 5,000 kilometers from each other. This indicator focuses on collaboration at a global scale. Like the impact indicators, each collaboration indicator has both a size-dependent and a size-independent variant. For instance, the size-dependent variant of the indicator of inter-organizational collaboration ranks universities based on their absolute number of co-authored publications, while the size-independent variant of this indicator ranks universities based on their proportion of co-authored publications. Unlike the impact indicators, the collaboration indicators don't use a fractional counting methodology. In the calculation of the collaboration indicators, each publication is counted with a full weight of 1. Users of the Leiden ranking often want to perform trend analysis based on the ranking. In the past, this was difficult because of methodological differences between different editions of the ranking. However, in the 2015 edition of the Leiden ranking, a backward perspective is offered that facilitates performing trend analysis. The Leiden ranking 2015 provides statistics not only based on publications from the period 2010-2013, but also based on publications from 4 earlier periods, 2006-2009, 2007-2010, 2008-2011 and 2009-2012. The statistics for the different periods are calculated in a fully consistent way, with in each period citations being counted until the end of the first year after the period has ended. For instance, in the case of the period 2006-2009, citations are counted until the end of 2010, while in the case of the period 2010-2013, citations are counted until the end of 2014. Finally, we will take a look at the website of the Leiden ranking 2015. My colleague Neesjan van Eck, who is responsible for the website, will give you a short demonstration.
We will now give a brief demonstration of the CWTS Leiden Ranking website. The website is available at leidenranking.com. Here we see the homepage of the website. Under Ranking, the latest edition of the Leiden Ranking is available, as well as previous editions. Let us look at the latest, so the 2015 edition of the Leiden Ranking. This page provides an overview of the ranking results. It is important to mention that it is not a static ranking. Using the controls at the top of this page, we can change the criteria based on which the universities are ranked, and we can filter universities based on, for example, region and country. Besides this, it is also possible to show the ranking for different time periods. We are now looking at the size-independent ranking of universities. In this ranking, the performance of a university does not depend on the size of its publication output. The advantage of the size-independent ranking is that it enables the comparison between smaller and larger universities, so for example between MIT and Rice University. By default, universities are ranked based on scientific impact. It is also possible to rank universities based on collaboration. Different indicators can be used to rank universities. By default, universities are ranked based on the proportion of top 10% publications, so the percentage of frequently cited publications. If we then look at the ranking results, we see that MIT is ranked first. Of the 750 universities included in the ranking, MIT has the highest percentage of frequently cited publications. Almost 25% of the publications of MIT belong to the top 10% of their field and year in terms of citations. MIT is followed by Harvard, Stanford, UC Berkeley, and Princeton. Like in earlier editions, the top 50 universities with the highest percentage of frequently cited publications is strongly dominated by US universities. There are just a few non-US universities. These non-US universities are from Israel, the UK, and Switzerland. If we, for example, are interested in a ranking of only European universities, then we can filter based on region. In the top 25 of European universities with the highest percentage of frequently cited publications, we see mainly universities from the UK, Switzerland, and the Netherlands. If you look at the size-dependent ranking, so if we rank the universities based on the absolute number of frequently cited publications, we see that Oxford is on top with 2,300 publications that belong to the top 10% of their field and year, followed by Cambridge with 2,100 frequently cited publications. By clicking on a university, it is possible to obtain a convenient one-page overview of all bibliometric statistics for the university. Here we see the impact results for MIT. A table provides an overview of both the size-dependent and the size-independent indicator values. A pie chart provides an overview of the publication output of a university per field of science. So in this way we get insight in the profile of a university, whether we are dealing with a broad university focusing on all fields of science or a specialized university focusing on only a couple of fields. A bar chart shows the impact per field. Reference values are also visible in the chart. Those reference values help to see whether the performance is below or above world average. Finally, we see a line chart that shows per field a time trend for a particular indicator. In the case of MIT, the percentage of frequently cited publications is quite stable over time for the different fields. We only see a very small increase for the biomedical and health sciences and a small decrease for mathematics and computer science. The same table and charts can be shown for collaboration indicators. If we then look, for example, at the time trend, we see that MIT is more and more publishing in collaboration with other institutions. We have now given a brief demonstration of the Leiden Ranking 2015 website. You can take a look yourself at leidenranking.com. If you want to have more information on the methodology of the Leiden Ranking, please take a look at the information under Methodology. If you have questions or feedback on the Leiden Ranking, please send us a message using the questions and feedback form under Contact. In order to be informed on developments related to the Leiden Ranking, please subscribe to the Leiden Ranking newsletter. I would like to thank you for your interest in the CWTS Leiden Ranking.